Hello everyone, let's look at the secant x equals -2 here. This is a trig equation that's also really simple, but this time we deal with a secant function, so that's more complicated when you deal with a single trig function that's like sine x equals some number or cosine x equals some number. And it's actually probably more difficult than the tangent one, but it's actually still overall quite easy. Okay, so we're still solving the equation on the interval from 0 to 2 pi. And if we look at this equation here, the first thing that we can do is that if you really just don't want to work with the secant function, then you can turn it into 1 over cosine and then just work from there. And then in that case, you probably need to do some algebra manipulation to get it in the right form. Or we can actually just directly work with the secant function and see how it goes. Okay, so this -2 right here tells you that you are not going to get a quadratic angle for this x as a solution. So we are going to draw the triangle. We are going to use the reference angle approach. Okay, so let's get started. First, I'm going to draw a right triangle. And this right triangle can be just a generic triangle, so we don't need to try too hard to think about which one, how long the sides are. I'm actually having a harder time picking which color is the right color for drawing it. Let me just use green again. Just do that. Okay, so we are going to draw that triangle. Okay, so let me just draw it like this. I think I need to draw a larger one so that last time when I was doing the other video, it was so hard to label when it's too small. So let's do this. And yeah, so we're just going to assume that this is the angle that we're looking at. Okay, so that's our angle. Now, what do? We're just going to ask ourselves, how do you write this -2 as a fraction? It's actually quite simple. We can write it as a fraction by putting 1 under it, right? We put the 1 as a denominator, and so we are going to write that as -2 over 1. Okay, now, just remember that for secant, it's the hypotenuse over the adjacent, so we can label the 2 and the 1 on there. Now, you may say, what about the -2? A side length cannot be length of -2, so we are going to ignore the sign right now. We just look at the number, the numerical value for the numerator, and then the denominator. What about the sign? Just ignore it right now. So we are going to put the 2 right here. Okay, so that's 2. And then the adjacent is the 1, right? So we are going to get the 1. And then, yeah, so I forgot to label the right angle. Okay, so that's good. And then as you can see here, this is, again, a 30, 60, 90 degree right triangle. And the third side, of course, will be the radical 3, the square root of 3. And then now we can actually label our angles. So the one that's facing the one, that's 30 degree. Okay, so it looks more like this one is a 30 degree, but we're not drawing the triangle to the correct scale. So whatever, right? We are just using this as a reference. Okay, so the one that's facing the square root of 3, that's 60 degrees. So we are going to get the 60 degree right here. Okay, so that's good. Now, the angle that we're looking at, it's really just 60 because that's the one that's that I indicated that that's the angle that we're looking at, and that angle happens to be facing the square root of 3, so that's the angle 60 degree. So we can now write down our reference angle, which in this case would be 60 degrees, so it would be pi over 3 if you're writing it in radian. Okay, so far so good. Now the next step is to determine the quadrant, and this time we are going to look at the sign. And so as I said, when we were constructing the right triangle right here, we just ignore the sign when we label the sides on there because it's unnecessary to include the sign for this one. Unless you're constructing it on the XY plane, then you can include the sign on there, but it's really unnecessary to do that. So right now we just need to look at the sign, and the sign is negative. That means we need to determine in which quadrants is secant of that angle equal to a negative number. And to do that, we use our usual chart for the sign chart for all the trig functions. So in this case, we are having You're just going to draw the chart right here, and it's actually quite simple to label the chart, which is what is that? All students take calculus, right? And so in this case, as you can see here, secant actually corresponds to the cosine function, right? So in this quadrant, cosine is positive. And in the first quadrant, of course, cosine is also positive. So that means in the other two quadrants, in quadrant 2 and quadrant 3, cosine would be negative. So that means those are the two quadrants that we are looking at here. This one and then the other one. Okay, so that means, let's write it down. That means the quadrant that the angle belongs to would be in quadrant 2 and quadrant 3. And those two pieces of information are the information that we need. The reference angle and then the quadrants that the angle lies in. And then we can write down our solution. Okay, so let's go back to the problem and start writing down our solution. Our solution in this case would be, one of them is in quadrant 2 and it's having a reference angle of pi over 3. And so that would be 2 pi over 3. It will be 2 pi over 3. And you may be wondering, what is this angle in degree, right? So we can also write it down. That angle, the angle in degree is actually 120 degree, because if you're adding the 60 to the 120, then you will get the 180. So that's being formed with the x-axis. And yeah, so that's quadrant 2. That's quadrant 2. That's the quadrant 2. Then you may say, what about the other angle? The other angle is the angle that's in quadrant 3 and also having the same reference angle. And that one is going to be 4 pi over 3, because 4 pi over 3 lies in quadrant 3. And then this angle, it's 240. That's obtained by adding the 60 degree to the 180, the negative x-axis. Then we are going to get the 240. And that's an angle in quadrant 3. And so we stop here because there are only two solutions that will satisfy this equation on this interval from 0 to 2 pi. Okay, and yeah, so that's it for this problem. We are going to look at a slightly more complicated problem next time. And if you like this video, please subscribe to my channel and then give me some support. Thank you for watching. I will see you next time.